Hello everyone, welcome back to my channel Mind Your Exam. In this video, we will be studying some very important terminologies related to Hamming distance, and we will find out what are block codes, how many Hamming distance apart must be two different block codes or code words to detect and correct errors. Okay, so starting with the basics, we have seen that at the data link layer, error correction and detection are important functionalities that need to be performed. So whenever there is a frame at the data link layer and we need to provide the facility of either error detection or correction, then the contents of the frame are broken down or are divided into two parts. Basically, a frame will contain m number of message bits, which are also known as data bits. Along with that, in the frame there will be r number of redundant bits. Now these redundant bits are also known as check bits. So the redundant bits are present because these are the bits that will be used for performing either error detection or error correction as per the requirement. Okay, and the combination of m plus r gives you a code word equal to n bits. So what is a code word? A code word basically consists of n bits where n is equal to m plus r. That means message bits plus the check bits combined together make n number of bits, and this is known as one code word. Okay, so the contents of the frame are being referred to as a code word here. Okay, where only we are considering the message bits, that is the data bits, and the redundant bits. Okay, we are not considering the headers and the trailers and as of now. Okay, so now comes the most important definition. What is a Hamming distance? Now whenever we have two different code words, that is when we have two different n bit combinations where n consists of message and redundant bits, then these two code words will have a certain distance between them, and that distance is known as the Hamming distance. Now what do I mean by distance? Distance basically means the number of bits that are different are known as the difference or the Hamming distance between the two code words. Okay, so if I have one code word, say 1000100, and this is another code word, say 1010110, then the number of bits which are different at the corresponding bit locations is known as the Hamming distance. Okay, so the number of bit positions in which these two code words differ is known as the Hamming distance. Say for example, we have these two code words and I have to calculate what is the Hamming distance. Then these two locations are exactly the same. That means at this particular bit location, the bit that is present is the same, whether it is both zeros or both ones, but they are same. Then at this particular bit location, that is the second last location, the bits are different, so the Hamming distance gets increased by 1. Okay, then at the third last location there are same bits, again the Hamming distance will not get increased because the bits are same. Here also at both the locations the same value is present, so we will not increment the Hamming distance, but at this location again the corresponding bits at this location are different, so again an increment in the Hamming distance. So this particular uh, pair of code word is two Hamming distance apart. Okay, now how do we find out for larger length code words that what is their Hamming distance, how many bit locations actually differ in them? So the method to do that is to calculate the XOR of the two code words. Okay, now how do we calculate the XOR? XOR basically is performed bit by bit. That means a XOR operation is performed between only two bits, corresponding two bits that are present at one bit location, and if the two bits are same, then the result will be 0. The XOR result will be 0. But if the two bits present at that particular location are different, then the result of XOR operation will be 1. So after performing the XOR for every location, if we count the number of ones in the result, we'll get the Hamming distance. So let us do this exercise for this pair of code words. Now here, let's start doing the XOR one by one. Now if we start from this side, then the XOR for this bit location will give you 0 because both the bits are same. So same bits results into a 0 in case of XOR operation. Similarly, at the second location also both the bits are same, so 0. Now at this location the bits are different, so the result of the XOR will be 1. Here the bits are same, so again 0, same bits, again 0, and here again at the second last location the bits are different, so a 1 will be there in the result of XOR, and at the last location another 0 because the bits are same. Now this is the result of XOR. So in this result you have to calculate how many ones are occurring. So the 1 is occurring 2 times, therefore the Hamming distance is 2, and that is how we calculated manually also. So whenever you have to find out at how many bit locations the two code words have different bit values, you find the XOR of the key code words. Okay, now if two code words are d Hamming distance apart, then you will require d single bit errors to convert them into one another. Okay, so d number of single bit errors required to convert one into another. Okay, now what does this mean? It means that if two code words, say here the two code words were different at 2 bit locations, so if one error is changing the value of 1 bit, then we will require 2 errors so that uh, two bits can be changed, so that one of the code word becomes another code word with which we XORed. Okay, and those changes should be at the locations where the 1 is occurring. Okay, so if we have to convert one code word to another code word, we will perform single bit errors. How many such single bit errors will be required to convert one code word into the other? D number of single bit errors, where D is the Hamming distance between these code words. Okay, so now let us come to the definition of a block code. Now code here means whether error correcting code or error detecting code. Which specific code we are talking, we'll consider it separately in the future videos, but for now generally when we are talking about code, we mean either we are talking about an error correcting code or an error detecting code. So what is a block code? A block code is a code in which the R check bits are calculated only using the M data bits. Okay, so we said that a frame consists of M message bits or data bits and R check bits. Okay, so when these R check bits, these R bits are computed only using M bits by applying any kind of function that uses only these M bits in some manner to calculate the R bits, then we say that the error detecting or correcting code that we are using is a block code. Okay, now if the R check bits being computed using some other values except for the M data bits, then we say that it is not a block code. Okay, now comes a very important part that you need to remember. So any error detecting or correcting code, if the code has d+1 distance, then it will be able to detect d number of errors. Okay, if a code has d+1 distance, it will be able to detect d number of errors. So only detection is happening here. But if a code word has 2d plus 1 distance, then it will be able to correct d number of errors. Okay, so if you have to detect d number of errors, you will require a code, an error detecting code that has d plus 1 distance. And if you want to correct d number of errors, then you have to develop a code that has 2d plus 1 distance. Okay, so we will talk in much more detail about a code having a d plus 1 distance in further videos when we discuss Hamming codes in detail. But for now, you must only understand that if suppose you have a code word, if you have a code. Now be careful in these terminologies. A code word is not equal to a code. A code is a error correcting or error detecting code, whereas a code word is a combination of M and R bits. Okay, so now a code that has a distance 5 will be able to detect how many errors? So let's calculate here. We know that 5 is equal to d plus 1. So if we have to calculate d will be equal to 4. Now, if we want to use this code to correct errors, then how many errors can be corrected? Then in this case, 5 will be equal to 2d plus 1. That means d will come out to be 2 in this case. So, a code with distance 5 will be able to detect 4 errors. That means it will be able to detect 4 errors, whereas it will be able to correct up to 2 errors. Okay, that means it will be able to correct difference in two bits. If there are code words that differ in 2 bits, that double errors have occurred, then this code with distance 5 will be able to correct them. But if quadruple errors have occurred, that means errors have occurred in 4 bits simultaneously, such errors will only be detected. Okay, so this was all about the important basic terms that are required for understanding Hamming distance and Hamming codes. Okay, so in the next video, we will be continuing with this topic and learn about more such error detecting and correcting codes. Thank you for watching. Till we meet in the next video. Mind your exam.